Hey guys, welcome to my machine learning series. The reason for starting this series is to educate people about machine learning algorithms and build complex machine learning algorithms. Let's get started. Problem statement about the likelihood of an applicant to receive a job offer through on-campus placement. Let's get started. The campus placement process is a crucial bridge between academic institutions and the job market. Yet it often lacks consistency, efficiency, and predictability. The project aims to develop a neural network model that can predict the likelihood of a student to receive a job offer through on-campus employment. I have identified 12 variables that are useful to predict the chances of an applicant to receive a job offer. The data that is used is gender, secondary education percentage, secondary education board, higher secondary education percentage, higher secondary education board, higher secondary education stream, undergraduate degree percentage, undergraduate degree type, work experience, employability test percentage, MBA specialization, and MBA percentage. Our target variable is the placement status, which indicates whether the candidate was placed or not. Let's get started building the neural network model. The first step involves loading the necessary libraries to build a machine learning model. Second step involves loading the dataset. Now we will understand the significance of variables using specific visualizations. We are trying to find the number of students that receive a job offer based on work experience and MBA score above average. 60% of the applicants receive a job offer without any work experience. 87% applicants receive a job offer with work experience. The next significance that we're trying to find out is the number of students placed based on work experience, specialization, and average MBA percentage. It is possible to find that applicants with marketing and finance specialization taken in MBA receives more job offers than applicants with marketing and HR specialization. Applicants with marketing and finance specialization taken in MBA with work experience and a score greater than average MBA percentage are placed more than applicants with marketing and HR specialization taken in MBA with work experience and a greater score than average MBA percentage by 21%. It is possible to conclude work experience is important for marketing and finance specialization taking an MBA compared to a marketing and HR specialization taken an MBA. Moving forward, the next step involves pre-processing the data. Different pre-processing techniques are used. The different pre-processing steps that are used are frequency encoding. Frequency encoding is used to convert features. It is used by dividing the frequency of different classes by the number of values. Second thing is label encoding. It is used to convert the target variable. Label encoding converts different classes in a column to different labels starting from zero. The third preprocessing technique used is normalization. It is carried out because it guarantees that every feature contributes equally, preventing large magnitude features from overshadowing others. The last preprocessing technique used is balancing the imbalanced target variable. It is used so that each variable gets importance and especially the minority class gets importance. Moreover, accuracy of the model will not be useful in this scenario because it can predict a majority class absolutely correct, but it might miss out on the imbalance class, which will give a high accuracy, but is not an accurate performance of the model. So let's move forward and execute the pre-processing techniques. Let's begin by performing the frequency encoding on feature variables. The next step involves performing label encoding on the target variables. The next step involves removing the target variable that is not numerical and removing the categorical values from the dataset to build our feature space to build a machine learning model. In this dataset, we can find that all our variables are numerical and can be used to build the machine learning model. In addition, we have to remove the serial number, which is a numerical variable, because the variable is insignificant to our analysis. So after removing the variables that are not required for the analysis, we have a total of 12 variables that we will be using to build our machine learning model. The next step involves normalizing the values. Here is all the values that are normalized to provide equal weight in predicting the likelihood of a person to receive a job offer through on-campus placement. The next step involves splitting the dataset into train, test, and validation set. The next step involves building the machine learning design. This involves creating the necessary factors and building the machine learning architecture. In this block of code, 60% of data is under the training set 20% of the data is under testing set, and 20% of the data is under validation set. The next step involves balancing the class weights which are imbalanced. The result shows that the applicants that are not placed are given more importance, whereas the applicants that are placed are given less importance in building the model. The next step involves building the machine learning design. So in this block of code, we have used the following parameters. We have selected the number of layers, the number of units, the activation function, and the learning rate. Number of layers specifies how many layers will the neural network model be. Number of units is the number of neurons in each layer. Activation function is linearity function that helps to understand relationships which are not linear. And we have given three options to select the best neural network model that can predict the likelihood of an applicant to be selected. The learning rate is the amount of time it takes to find the best model. In other words, you can say it as the time taken to find the best weights. In compiling the ANN, Adam Optimizer is used to update weights, which is the combination of momentum and RMS prop in updating the learning rate. Adam adjusts the learning rate based on both the average of recent gradients, which is the momentum, and the magnitude of recent squared gradients. Binary cross entropy is a loss function that is used to validate between actual values and the predicted values, penalizing the model when the predictions are confidently incorrect. Prediction confidence is the level of closeness of the predicted probability to 0 or 1. The next step involves incorporating the Bayesian optimization technique. Optimization techniques are used to find the best model that can be used to predict the likelihood of a person to receive a job offer. It involves selecting the best configuration based on different hyperparameters. Bayesian tuning works by building a hypermodel based on the predictions of previous hyperparameters. Moving forward, let's build the Bayesian optimization method to find the best model. In this, we are trying to find the best configuration using the Bayesian tuner. There are a total of two layers. The base layer has 192 neurons and an activation function of tan h. Learning rate is 0.05. The first layer has 32 neurons with an activation function of ReLU. The second layer has 224 neurons with an activation function of tan h. The next technique that will be implemented is the early stopping technique. Early stopping technique is used to avoid overfitting. It works by setting a patient's parameter and min delta parameter. Patient's parameter is used to check the number of epochs to be run that satisfy the min delta parameter. Min delta parameter is used to check the change of loss in the validation set. So by running the epochs, we find that the best training accuracy is 88.37, validation accuracy is 81.39, validation loss is 58.9, and the training loss is 39.64. The graph shows how the train accuracy is improving and validation accuracy changes after each epoch. The next technique that we will be using is the hyperband optimization technique. Hyperband tuning is used to find the best parameters by allocating more resources to promising configurations. A reduction factor is used to find the best parameters. It works by having all parameters and assigning very minimum resources, and after each round it reduces the number of parameters to a given number based on the reduction factor. Iteratively, it works until it finds the best parameter and allocates more resources to the best configuration. Let's implement the hyperband optimization. Again, in the hyperband optimization, our objective is to minimize validation loss. that can be used to train the model. Using the hyperband optimization technique, we found that the ideal neural network design is a total of two layers, where the base layer has 160 neurons and an activation of ReLU. The knurling rate is 0.01. This first layer has 256 neurons with an activation function of tan H. The second layer has 192 neurons with an activation of LERU. Using the Using the hyperband optimization technique, we found that the best epoch is epoch number one, and it has a training loss of 0.164, validation loss of 0.28, training accuracy of 0.95, and a validation accuracy of 88.4%. Lastly, our aim is to just visualize the confusion matrix, which shows how many accurate predictions and how many predictions that were made correct for ones that were not placed. This shows the confusion matrix for the Bayesian technique. Now we will find the confusion matrix for hyperband technique. Overall, we can find that the test accuracy using the hyperband technique is more than the Bayesian technique. The hyperband technique accuracy is 84%, whereas the Bayesian technique is 77%. That's all, folks. If you have anything to share, comment on the video link below. And I look forward to sharing more information and learning more information together. Like the video, and I'll see you on the next machine learning video.